We're from group 2. We're going to explain the potential energy, how the potential energy change any molecules through any chemical reaction. And with me, I have Agogo and Roxanne. We're going to explain this reaction, right? Agogo going to write all those charges.
Right now, in this reaction, there is too much repulsion, so we're trying to make it more stable. The oxygen has partial negative.
No, partial negative is like negative, the whole negative.
Oh yeah, it does.
That.
And this partial positive. So you know.
That's right. Okay. In our reactant side, we have OH minus, hydroxyl minus. We have 3 lone pair of electrons. So oxygen have total negative charge on it, as you can see. It has more electrons than it's supposed to be. So this is too much repulsion. Oxygen shell. This is too much repulsion going on in outer shell, right? So this is the potential energy for this oxygen is way higher now than regular. So say the oxygen potential energy is something like that and above. So it's less stable. And the other reactant, we have chlorine here, which is more electronegative than the carbon. So it will pull the electrons in the bonding area more towards it. So carbon gonna have partial positive and chlorine having partial negative. So my unstable oxygen's electrons will look for some positive area, look for some place to give away electrons. So the most positive we could find here, carbon and hydrogen also. So this is better to give the carbon here, these electrons. The best way to give away the best positive carbon is this one. Sorry. And then that's what we're going to do. This carbon will have the sp3. Sorry, this sp3 hybridized. So as I'm doing this, and this chlorine pulling more electrons towards, so it's partial positive and partial negative. And this minus charge will find this positive, and then it will come closer. This OH will come closer to this positive, partial positive. As soon as they're closer, so here is going to be too many repulsion, because these electrons in the bonding area, they will start to get pushing back. So that's where my potential energy going higher again. It's going up. So here my potential diagram, it was here, this oxygen, OH minus, or the reactant I rather say, they were here at the beginning. So as long as my OH minus coming with this negative charge to this carbon, and now it's like too many repulsion going on, my potential energy will going out. Somewhere in here. So here we're going to have our transition state with this chlorine and the oxygen coming from the backside. Well, one more thing, the hydroxyl minus cannot come in that top side because there's too many negative leaking out, negative negative charge leaking out by the chloride ion. Then, so our only way to coming out from this back or from this top, but there are still 2 hydrogen there, so it's best way to come in from the down, from the backside attack here. So we're gonna have here too many repulsion by this all lone pair, the electrons in this bond, electron in this bond, hydrogen carbon, carbon chloride, and also these electrons. So my potential energy is going up, and then this, since this electrons feeling too much repulsion here, and it will go through the chloride. So electron here just come to the carbon, and these electrons in the bond, they will go to the chloride. So and then we're gonna get this CH2OH. Carbon, oxygen was before 3 lone pair. It losing 2, so it's now 2 lone pair. and it was negative before since it's losing electrons and using neutral. And the chloride, it's gaining electron from there. It was neutral before, now it has more, it has a negative charge because it's gaining the electron. Now let's see the product. The electrons in the oxygen before, it's feeling so many repulsion in the carbon shell, oxygen shell. They're wearing higher in the potential energy. But these electrons are now in chloride, or you rather say, yeah, if you want to tackle like that, this chloride now getting the electrons rather than oxygen. This chlorine have bigger shell than oxygen, which can handle electron better because it has more space. So this is less repulsion. Less repulsion means more attraction. The way to say are less potential energy. That's where my product is here, is less potential energy and more stable. Less potential energy. The product there. Less potential energy. So more stable. If you want to compare the whole thing again, this electrons was in oxygen, smaller shell, too much repulsion, higher potential energy. Then it goes to the carbon, and this oxygen loses the electron, become neutral, and this chloride now getting electron. So the minus charge we had before on the oxygen, too many repulsion, higher potential energy, now have minus charge on a chlorine, which is better than the oxygen because it's more bigger shell, can handle electron better, less repulsion, less potential energy. That's why you're getting more stable product, and that's it. Your exothermic process, your equilibrium will be favored to the product. So yeah, that's how we get it done.